Okay, so exercise 5.3 on scalar multiplication. I've given you a lot of those basic calculation questions. So all you need to do is just multiply them together, add if required, subtract if required. Check your answer at the back. Okay, so for question 3a, I have no doubt that you can actually do 3a and 3b. So make sure you double check your answers at the back. I'm not going to go through the actual calculation. Rather, what I'm more interested will be in part C. What is the relationship between scalar H multiplied by scalar K multiplied by matrix A versus the two scalars multiplied together first, then you multiply by the matrix. So it turns out they are the same. So for part C, H and then K times A is actually the same as H times K, then multiplied by A. Okay, you should have a relationship. And then question 4, turns out that these two are the same also. So you can apply your distributive law. Okay, that is something that we learned in lower secondary, where things like this in your algebra, 2 times, okay, let's talk about numbers first. 2 times of 3 plus 4. We know that it's 14, right? 3 plus 4, 7 times 2. You can actually do it this way. This is our distributive law. So 6 plus 8. And you also get 14. And then in algebra, it is the same thing. 2 times of x plus y is 2x plus 2y. In the same way, our matrices, scalar multiplication of matrices, 2 times of p minus 3q, you get 2p minus 6q. They are the same. Okay, so this is our answer for part C. Okay, next one, question 8e. Over here, you have to do some manipulation. Make the q, group the q terms, the p terms together. So our first step will be p minus half p will be equal to -3, -1, 2, -3, and 4. So I'm treating the matrices like your usual algebra. Whatever you do on one side, you do on the other side. And then when it comes to the next step, you get half p. You multiply your -3 in, you get 3, -6, 9, and -12. Subsequently, p is just multiply everything, every element by 2. So 6, 18, -12, -24. Am I going too fast? If I am, let me know. Next, question 10. So here we have some solving for values of x and y. So there are, in this case, question 10, there are 2 different types of question. The first one, you can simply take 4 times of 3x minus 3x, you get -y. And this is our first equation, which you can simplify. Okay, maybe let's simplify it first and we call it equation number 1. So from here, we get 12x minus 3x, 9x equals to -y, equation number 1. So you see that it looks like simultaneous equations already. And then second equation, 4 times of y minus 6y is 12. This is my equation number 2. So I work from equation number 2, -2y is 12, y is -6. Sub into 1. Okay, so substitute into 1, 9x is -6. X must be 2/3. Is the answer correct? Okay, so that was 10a. We're doing simultaneous equation. So 10b, you do the same thing. You have 2 equations in n as well as m. So go and check your answer by yourself. If it is not correct, you need explanation, let me know now. So does anybody need me to go through 10b? No need. Move on to 11. Okay, so annual salaries for these girls, a matrix representing that will be 1 year, 12 months. So 12 times S. They didn't specify what you should call the matrix for the annual salary. So I just used the letter A for annual. Okay, so just multiply by 12, you get the answer like this. And then for question 12, 12a, every height increased by 20%. So 20% is just 20 over 100, which in your calculator tells you 0.2. So my height will be, the increase in height will be 0.2 times the matrix X, giving me this matrix. And then the new height, you can take the original plus your answer in part A. Alternatively, the new height is just 1.2 times of the original, and you get the answer as such. So many ways of doing it. Okay, so yeah, that's all the question for the weekend. Okay, anybody needs to go through anything else? If not, yes. 8E. Okay, if you're done with this already, please pass your work down. Yes.
Because I put 100, I put 120%.
120% you minus off what? You're doing part A or part B? Why need to subtract one? Okay. So this was the question. You're talking about this book right here, right? 3.6. You see, there's a problem in your presentation. I can't tell whether this is like 33 and then 64 or you need to give bigger spacing. So you're saying that you did part A by taking the answer in part B minus the original, is that it?
Yeah.
Then you must show me that you're doing that subtraction. Anyway, how do you get the answer for part B?
I think the value times 120%.
But it's not shown here. You must at least write it down. Look, I just wrote 1.2 times the original matrix. So presentation, all you're missing a lot of things. What is this? What is this over here? No, I didn't do anything like this. Question 10. See, I never did anything like this. This will not give you any marks.
Because I expanded.
How do you expand? Okay. So you expand 4 times 3x. So you get 12x. Then minus 3x, right?
Yeah.
You didn't write 12x minus 3x. What you wrote was column vector 12x 4y multiplied by negative 3x negative 6y. So you may know what you're doing over here, but you came out with your own presentation, which is mathematically wrong. So everything is wrong over here, even though your final answer might be correct. Okay, so do it the proper way. Yes, submission? Huh? Submission. Okay. Okay, so now we go on to the slightly more challenging one on multiplication of matrices. So multiplication of matrices is different, entirely different from scalar multiplication. Scalar multiplication is easy. Just multiply every number by a fixed number. But matrix multiplication throws up a lot more things that you need to understand. For example, the meaning of every element after you do your matrix multiplication, you need to explain what they represent. Thank you. And in matrix multiplication, there are some restrictions. You cannot multiply any matrix you like with any other matrix. The order matters. So right from the start of our matrices, I taught you how to identify order of a matrix, row and then column. So without knowing how to identify row and column, you are unable to do your matrix multiplication properly. Okay, so now set aside your homework first, whatever it was just now. If you need time, you can submit it later at 4 o'clock. Right now, I'm going to recap on what you should have learned yesterday. Okay, so let's take a look at these two matrices over here. What is the order for matrix A? What number by what number? So how many rows? We got 3 rows. How many rows? 8. 2 by 3. What about the other matrix B? 3 by 2. You can only multiply 2 matrices together if these numbers are the same. Okay, I can only write the matrix multiplication A times B only if the two highlighted numbers are the same. So the two inner numbers, put them side by side, the two inner numbers are the same, then you can multiply, otherwise cannot. Impossible. And then what is the resulting matrix? After that, A, B, okay, the answer, the order will be, you copy down this number, copy down this number. In this case, it happens to be 2 by 2. So there are 2 rows and 2 columns. This is the order that we expect for the final answer. Okay? Okay, so let's look at example number 14. I'm just going to talk about the order first. Matrix A, what is the order? One quickly. Order. 2 by 2. What about B? 2 by 2. Can multiply A and B? And these two are the same. So what is left? After you multiply, AB will be of order 2 by 2. As shown over here. 2 rows, 2 columns. Don't worry about the inside first, although you should already know from yesterday. Just talk about the order. And then we have this thing called B times A. Earlier on we did A times B. Now B times A, because they were 2 by 2 matrices for each of them. Our final result is going to be still 2 by 2. But our answer for AB versus BA, so AB is highlighted in green, 6, -48, -3, -52 is entirely different from this matrix. They are absolutely different. So in primary school, we learned that 2 times 3 is the same as 3 times 2. In algebra, it is also the same. But when it comes to matrix multiplication, it is not the same. Okay, it may happen that they have the same result, but in general, they are not the same. Okay, so we're gonna skip try 14. Okay, now try it 15. Identify whether they are possible or not. Okay, so I want you to quickly write out the order for every one of these matrices. Just write it at the bottom. Okay, quickly take your pencil and start writing. So this will be 2 by 2. Then keep writing. They ask you to do this in the video, right? They ask you to do it in the video? I'll do already. Okay, so you will have 2 by 3, 2 by 2, and 2 by 2 again. Okay, so AI. I is the identity matrix. Identity matrix, in matrices, right? It is just like the same as multiplying by 1. You know, number multiplied by 10 times 1 is still 10, right? -8 times 1 is still -8. Matrices has something like that. It is called the identity matrix. It looks like this for a 2 by 2 matrix. Instead of ones everywhere, it is all 0 except the diagonal down. It's all 1. Okay, that's our identity matrix. So AI, it is possible we will get a 2 by 2 matrix. And then after you multiply out, you will get AI equals to, you get back the same after you do the multiplication. That's why it's called the identity matrix. You get back the original. Okay, so so on and so forth. This should have been covered in the video already. So all these identity matrices, they are all square matrices, all zeros, except this diagonal, they are 1. Okay, so here AO and OA are 0 matrices, just like 0 times 1, 0 times whatever, 1 times and whatever times 0, you still get 0. So 0 matrices. Answer is going to be 0, all zeros. Then AI is the same as IA, which is where I is the identity matrix, and generally these two are not the same. Okay, so no such thing as matrix divided by matrix. You have matrix divided by scalar, have matrix times scalar, have, but this no such thing. So I wrote it very big because it is very tempting later on for you to try and take matrix divided by matrix. Very tempting, but you must know that it doesn't exist. There's no such thing. You must know it now. Okay, then in the video, I covered until example number 16. I showed you how to do the multiplication. Row, then column. Okay, now in AB, matrix A shows the number of coins. So header, I also talked about it, very important. Matrix A, put here 20 cent, and then 50 cent, $1. Over here, we have wallet 1, wallet 2, wallet 1, wallet 2. Matrix B, we've got our 20 cent, 50 cents, and $1. Okay, in addition, one thing they didn't show, matrix B shows the mass in grams. So this is the mass. When you multiply matrix A and B together, I want you to pay close attention to the header. Look at all the headers. Is there something that you notice? The headers? Anything that's repeated in the headers? Right, 50 cent, 20 cent, $1, right? They are repeated. And remember, I said that the order matters. This is 2 by 3. This is 3 by 2. You only can multiply if the inner numbers are the same. So I'm going to highlight this 3 and this 3. The first 3 that I highlighted refers to the number of columns. The 20 cent, 50 cent, $1, right? Corresponds to this. The second 3 that I highlighted refers to the number of rows, which correspond to your 20 cent, 50 cent, $1. It's 3 by 1, 3 by 1. I write 3 by 1, yeah, 3 by 1. So you see the highlighted portions, they have to be the same. If they are not the same, cannot multiply. Okay, so this is one very quick check that we have to do first. Only if they are the same, then we multiply. Now, we also talked about after you multiply, you get a new matrix with a certain order, right? So I say that the inner numbers must be same, remove them. What is the resulting order of the answer? Order 2 by 1. Yes, over here, 2 by 1. Now, what do you suppose I should write for the header here as well as the header here? Yeah, okay. So I need you to think, you need to guess. After I remove all the yellow ones which are the same, my resulting matrix is 2 by 1. The 2 came from matrix A, 2 rows. What do you suppose I should put inside these 2 blanks here? Here and here. Wallet 1, wallet 2 lah. You just copy down whatever header was not used. Whatever is left over. Put down wallet 1, wallet 2. So what about the one on top? Mass. Yes. So after you multiply your matrices, you will end up with an answer with the order with the headers that remain. Okay? So the inner headers, the 3, 20 cent, 50 cent, $1, those that are the same, remove already. We're only left with wallet 1, wallet 2, and mass. So now the interpretation, what does the matrix AB represent? Or they can say explain what the elements inside AB represents. Our answer is here. They refer to the total. Remember our keyword, total. Total, what else do we have? Mass of the coins in wallets, in each wallet respectively, or you can say wallet 1, wallet 2 respectively. Okay, so all your headers are in, the word total is in, the mass is in, the word respectively also required. Okay, so if you follow my approach of how you multiply them together, remove the common headers, the resulting headers will tell you, it will tell you what it represents. So in this case, the word total, because we are adding, we're doing a lot of addition when you do your matrix multiplication. Okay, now you try it 6. You do try it 6. I do already. Yeah. Oh yeah, I asked you to do it in the video. Okay, yes. So Q times P. Over here, matrix Q is a 1 by 3 matrix. Matrix P is a 3 by 2 matrix. So the inner numbers are the same. After I multiply, I will get 1 by 2, meaning 1 row, 2 columns. Now I'm going to put in the header so that I know what matrix QP represents. Very quickly put on the values. The header, I mean. So 2, 5, 10, just follow lah. A, B, C, referring to section A, B, C. And then these are the marks allocated. So I put over here marks. Okay, section A, marks allocated, marks awarded for each question is 2 marks, and so on and so forth. And then our 8, 7, blah, 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 this is our Thai, Doris. And then our section A, B, C again. It is not a coincidence that it's the same. It has to be that way. So after you do your matrix multiplication, 1 row remaining refers to marks. Because all these, same, cancel away already. The 3 and 3 cancel. So left with Thai and Doris. So what do you suppose the elements represent? Marks of Thai and Doris, respectively, but there's one missing keyword. Total. Yeah, okay. So here, our answer for part B, it represents, no, not it, they. But the matrix, the elements are, okay, it represents, the elements represent on scan. The matrix QP represents total number, total marks, right? Total marks, Thai and Doris obtained respectively. So I don't need to talk about A, B, C anymore already, because it disappeared already. Okay, now example number 17, you can go and read it yourself. Try it 17 is the work you need to do right now in class. And then I will give you your homework question also. These homework questions, you can work on them in class tomorrow. Okay, so question 1, A, B, C, E, F, G. These are the work to be done tomorrow in class. Exercise 5.4. 1, A, B, C, E, F, G. Some warm-up questions only. And then question 3, question 4. You have 2 periods tomorrow, so you have time to do. And then question 8, 11. So exercise 5.4, question 1, A, B, C, E, F, G. Question 3, question 4. And then you move on to the next page. Question 8, 11. And then you move on to the next page, 16. Okay? Huh? I will tell you again on Thursday. Okay, so right now, please start on your work. If you need help with your matrix multiplication, let me know.